Okay, so here we are taking a look at the example that Victoria provided for finding the solution to 32 minus 12. And at first glance, this looks like it's just overly complicated, very convoluted. But there is actually some solid mathematical reasoning behind this algorithm. So when we're doing subtraction, 32 minus 12, we're also, another way to think about it is finding the difference between 12 and 32. How far apart are those two numbers? A young child, maybe first grade, second grade, may have a little bit of a hard time working with numbers up into the double digits. So they may feel more comfortable adding in their head to numbers that are multiples of 5 or multiples of 10. 5, 10, 15, 20, they're easier numbers to work with. So it seems like in Victoria's example here, a child might say, well, I'm not sure how to go from 12 to 20 yet in my head, but 12 to 15 is easy. I just add 3. And 15 is a nice, easy number to work with, because now I can jump from 15 to 20 very easily. Right? I just add 5 more. And then, of course, I can go from 20 to 30. That gets me even closer to 32. That's a pretty easy jump. I'm just adding 10. I only have 2 more to go from 30 to get to 32. So there we go. So now, adding up all of your jumps, the total distance you did is 3 plus 2 is 5, plus 5 more is 10, plus 10 more is 20. Now, another child may look at this example and say, oh, I can actually do, I notice that both of these numbers have a 2 in the ones place. So if I add 10 to 12, that'll take me to 22. And then if I add another 10, that'll take me to 32. This sort of mental reasoning for older children can help them solve something like 120 away from 320. So an older child might say, oh, in my head, 120 is 80 away from 200. And then I'm going to add another 120 to get to 320 from 200. Altogether, that's a jump of 200. Hope that helps.